Hey everyone, thanks for watching today's video where we're going to do a quick video on cylinder surface area. So just to flashback, remember that surface area is the measurement on the outside part of a shape, and remember the formula for the area of a circle is A equals pi r squared. Then also remember the formula for circumference, which is 2 pi r or pi d. Circumference is basically perimeter around a circle, and obviously area is the area inside a circle. So a lot of people get confused with what circumference is. It's basically perimeter. Okay, so now surface area of a cylinder is 2 pi r squared plus 2 pi rh. And I want you to see what this is really doing. So 2 pi r squared, that one's quick because we just said A is pi r squared, so this is just 2 times area. And then this one, what does this one look like? Well, 2 pi r, I know that's my circumference, so this is circumference times height. And now try to think about why this is going to be the surface area of a cylinder. The surface area is the area on the outside. So obviously you have this circle right here, you have this circle right here on the bottom. So that's where you get 2 pi r squared, 2 times the area of a circle. Then now the circumference times the height, that's this area that you get on the side right here, and the area you get on the side right here. You imagine it going all the way around, so it's really just the perimeter of the circle a bunch of times multiplied by the height, which represents how tall this cylinder is. So that's why it's 2 pi r, so the circumference times the height, and then plus 2 times the area of the circle. So this is a really intuitive formula, one that you shouldn't really have to memorize. You should be able to kind of reason through it and hopefully get to this answer. So now let's just do some quick practice with the formula. Find the surface area of a cylinder with a radius of 4 and a height of 10. Let's just quickly sketch what we have. So we've got the 2 circles here. Then we've got the height connecting them. Sorry, hard to draw straight lines on this thing. All right, that'll do. So then we have a radius of 4 for the bottom circle. So this is 4. Then we have a height of 10. So all the way to the top is going to be 10. And we want to know the surface area. Okay, well my formula is surface area equals 2 times the area of a circle on the bottom, which is just pi r squared. So 2 times pi times 4 squared. Plus, and now I'm going to do the circumference, which is 2 pi r, so 2 times pi times 4, and I'm going to multiply that by the height, which is 10. So now surface area equals 2 times 4 squared is 16, so that's going to be 32 pi, plus 2 times 4 is 8, times 10 is 80 pi. And that gives me an answer of 32 plus 80, which is 112 pi is the surface area of this cylinder right here. So that's what we did here. We did the circumference times the height, which is the 2 pi r, and that's the 2 pi times 4, and then times the height of 10. Then here we did 2 times the area, which represents the area of this circle and this one, and that the area formula is just 16 pi, because pi r squared, then multiplied by 2. So that's how we got that surface area. So let's look at one more example here. Find the radius of a cylinder whose surface area is 120 pi and a height of 5. So the cylinder has a height of 5 and a surface area of 120 pi. Let's just plug this into our formula. So I've got 120 pi equals, well, I know it's going to be 2 times pi r squared, plus, now I'm going to have 2 pi r times the height of 5. Okay, so that's good because now I only have one variable left and I can solve for r. Not an easy problem, but I can still get it done. So what I'm going to do is I'm going to get 2 pi r squared plus 10 pi r. Then I'm going to have that equals, well, 120 pi equals all that. But now I'm going to bring the 120, this is a quadratic, right? Because we have r squared, then we have r, and then we have something with no r. So this is a quadratic. We have to use our, not necessarily the quadratic formula, but we might have to use it. So I'm going to bring the 120 pi to the other side. So minus 120 pi. And now we try to solve the quadratic. So the way I would do this is I would first multiply this to get r squared by itself in front. So I would say r squared equals, or r squared plus 10 pi r minus, now what's 120 times pi, 2 pi? That's minus 240 pi squared. So now what we're looking for two numbers that will multiply into 240 pi r squared and add into 10 pi r. And let's think about this quickly. I just think of 12 and 2 immediately. But that would be 120 and 2 here, so that's not going to work. What about 40? Can 40 go into 240? 40 and what? 5? That's not going to add to 10. So just a quick analysis makes me feel like we should just do the quadratic formula. So let's go back here. So we're going to erase this step and go to this step and apply the quadratic formula to solve for r. So the quadratic formula, as you know, is negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. And that's what we have here. So negative 10 pi. Be careful here because the r is considered the variable. Don't get confused with the pi. Pi is just a constant, so that's what we have to treat it as here. So negative 10 pi, that's just a constant number where r is our variable. So b is 10 pi in this case, and a is 2 pi. Okay, so now back to our work. So plus and minus the square root of b squared, which is 10 pi squared, minus 4 times a, which is 2 pi, times c, which is 120 pi, actually negative 120 pi. Okay, all divided by 2 times a, which is 2 times 2 pi. And so this will give me negative 10 pi plus and minus the square root of 100 pi squared. So minus 4 times 2. What's 4 times 2 times 120? Well, 2 times 120 will give me 140, or 240, and that's a negative. So negative 240 times 4 is going to be 960. So positive 960 pi, or pi squared. Again, pi squared because of this. Because this is, well, no, because you're multiplying by pi times pi, so that becomes pi squared. All divided by, again, now this will be 2 times 2 pi will become 4 pi. Okay, so now what do we have here? We have negative 10 pi plus and minus the square root of 1060 pi squared divided by 4 pi. And r equals this. But we got to be careful here because one of these is going to give us a negative answer and one's going to give us a positive. So right now it looks like we have 2 solutions, but we really only have one. Because if we're taking negative 10 pi and we're subtracting the square root of 1060, we don't know the square root of 1060, but we do know it's something greater than 10, right? Because the square root of 100 is 10, but we have the square root of 1060. So it's going to be some fairly large negative, like maybe, I don't know, like 35 or something, roughly. So if we had negative 10 pi minus 35 pi, that would be negative 45 pi. But our radius can't be negative. So we really need to check our solutions here. So let me write out what I'm doing here. I'm thinking of our 2 solutions because this plus and minus gives us 2 answers. So negative 10 pi plus square root of 1060 pi squared. This is one of our solutions, divided by 4 pi. And then we're also saying there's another solution, r equals negative 10 pi minus square root of 1060 pi squared divided by 4 pi. But what I'm saying is that this solution is not going to be correct because this is going to be a negative, so equals a negative, and radiuses cannot be negative. It's got to be a positive number, so that is wrong. This is the radius of our circle. So this is a really complicated one. If you can do this one, you can do all of them. I recommend you go back and kind of rewatch what I did here. Being able to recognize that we had to do the quadratic formula, that can be tough at times. And this was a tough one to use the quadratic formula for because you had to know to treat pi as a constant. It doesn't affect the value. It's not a variable. So that is what r equals. And thanks for watching. Let me know if you have any questions.